put together a handout we can give out at the end, kind of summarizing a little bit. I think the biggest question that most people want to know for an engineer is how much money can you make, for any job, right? Like, we don't work necessarily because we just want to volunteer our time. We work because we want to have an income and we want to make a living. So I have some information I'll hand out at the end that you can take with you. But I thought that I would start a little bit just kind of explaining how my career started. I was in high school, and back then you would take a test, right? You would take the traditional test, what do you want to do with your life test? And with that, I scored well in math and science. And so it made sense for me. They give you a list of the jobs that you could do, doctor, 12 years of school, no thanks. It was just, you go through the list. Engineer was a 4-year degree, made a pretty decent living. I think I can do that. So I went to school. I got a bachelor's in engineering, and I decided, because Amy was still in school at the time, that I would go ahead and pursue my master's degree. So I went ahead and got a master's degree. So that was done before we had kids, and everything was out of the way. It was all good to go. So that's what the path, if you're interested in engineering, I would definitely start with the bachelor's program. And then if you wanted to get an MBA, that is what I think helped accelerate my career in engineering overall. Not initially when I first got it, because I was still fresh out of school when I first got it, but overall I think that helped me move up through the ranks. So when I first started, I was working in a manufacturing plant. We made brake corners. And brake corners, if you're not familiar, I know some of you guys work on cars, so you're more familiar, but that is the part of the vehicle that the wheel attaches to. And so you have the caliper, which actually squeezes against the rotor, and the rotor is what turns. That's how you stop. Okay, so when you push on your brake pedal, that squeezes the caliper together, compresses the brake rotor, slows the car down. There's also a bearing that turns. That's how the wheel turns. And they have what they call a knuckle. And the knuckle is what everything bolts to, and then how it bolts to the car. So we made that whole assembly, and I was responsible for multiple assembly lines that built those for many different vehicles. Our main customer at the time was GM, so we made a bunch of GM brake modules or brake corners. And so I started off doing that, and then after about a year, I moved into a different position, more of advanced manufacturing position, where I actually got to buy the equipment that built the machines, or that built the brake corners. So I was responsible to make sure that the equipment came in, that it was working, operating, everything was functioning correct, made good quality parts. We didn't make scrap. And so that was part of my responsibility. So I had to make sure that we did that, and obviously the equipment had to be delivered on time, in budget. And I actually bought 5 assembly lines and one, they called it a drag test stand. So again, when you apply the brake pedal, how fast does the caliper retract? How much drag is there still on the caliper while the corner's running? And so I developed a stand that tested that. So that was kind of how my career started. But that's the interesting thing about engineering, is once you start, you don't have to keep doing the same thing. So my career at that point then took a turn, because I started working with capital management. So I was still a manufacturing engineer. I still had responsibility. I was still in the group. But now I was responsible for all of the capital projects. So I remember I talked about buying the equipment. So within that, I had a budget, right? So with our whole group, we had a budget. It was like a $30+ million budget that we had for chassis modules globally. And so I was managing that whole budget for the division for a couple years that I was able to do. Actually, I think it was about 3 years. So again, that wasn't directly in the engineering field, but because I had my master's degree, I was able to get into more upfront in the business with managing the accounts. And I think, again, I mentioned how that helped accelerate my career, because it gave me opportunities. It opened doors that wouldn't have necessarily been open had I not had that. From there, my boss called me and said, hey, we need some help in China. So can you go over to China for a couple weeks and just help them out? Well, that couple weeks turned into 2.5 weeks, which turned into 3 weeks. I got to come home for 5 days, and then I went back for another 2 weeks. And the next thing I knew, I was the Asia Pacific engineer supporting programs in China and India, in that whole region, basically. So again, engineering also gives you the opportunity to travel the world if you're interested in doing that. We got to see the Taj Mahal. Never in my life would I have ever dreamed that I would go see the Taj Mahal. It's kind of cool. I've been to the Great Wall of China. That's kind of neat. You get to see some different things. Through my career, I've also been to Europe, lots of places, Portugal, Spain, Italy, France. There's lots of opportunity to travel if you're interested in engineering and you're interested in traveling and seeing the world. So there is something else for you to consider as well. But from there, I came back after traveling to all these different places. I realized that with a young family, that's going to be really difficult, right? Nathan was, 18 months old when I first started traveling, and Cora was just born, and so we had 2 young kids at home. Amy was doing everything by herself. I talked to my boss, said, hey, I can't do that anymore. So I went back to the plant, and so now I was back responsible for the equipment in the plant. I became a supervisor, and I led the engineering team in the plant over, again, assembly modules, because that was where my experience was. And so I worked in that capacity for several years until I moved into machining. So again, it's manufacturing, machining, you guys are familiar with that. So then I led the machining group for a few years before I moved into quality. So then I became the quality manager for the plant, and I had to have responsibility for all of the equipment in the plant, so rotor machining, knuckle machining, and assembly for the plant. It was about 650 million square foot facility at the time, so it was kind of small. And we had, I think at the time, we had about 50% of GM's brake corner business. So if you look at the GM manufacturing as a whole, they have a lot of vehicles they make. We produced at least half of their brake corners for them. So it was a large operation, so it was a lot of responsibility. And so I was able to manage that. So as a part of running the operation from quality is that you have to, again, have relationships with the customer. So a lot of engineering is networking. A lot of engineering is building relationships with people and just being able to solve problems. That comes natural, right? You would think engineers have to solve problems. There's math problems, science problems, et cetera. But there's also people problems. There's also equipment problems. There's also all kinds of other problems that we have to solve on a day-to-day basis, and it just depends on what you're working on. Through that experience, I met a lot of different people, and I got a lot of great experience there. I ended up transitioning to the engineering manager position, so I was back in manufacturing engineering, back in mechanical engineering, if you will, and so I was able to do work in that capacity. So through that time, our plant was transitioning, GM was resourcing things, and our plant ended up closing. But because of the networking, because of the opportunity to build relationships with people, when the plant closed, my last day was on a Friday. I started my next job on Monday because I had already built relationships, and those people knew that I was going to become available for work, and they reached out to me and asked me to come work for them. And so it's very important for you as you're developing and you're growing to learn how to interact with people. Some people you won't get along with. You won't get along with everybody you work with. You may not even get along with your boss, but you still have to learn how to work with those people, right? You still have to know what it takes to work together to solve problems in teams and with different groups of people with different goals, right? Quality has a different set of expectations than manufacturing, who has a different expectations than the industrial engineering group, right? Everybody has different goals. They're all working to a different end, but somehow you have to get everybody together, get them all aligned, and work towards the same goal, and that's what is so important about relationships and about networking. So, I don't know, is there any questions with that so far? That's a very good question. So if you didn't hear his question, he asked when I started, did I think it was going to be as much involved with working with people, or would I expect it to be in, more in isolation? And I think I would lean towards the latter. I didn't anticipate the working with groups as much. I mean, certainly in school, you're in group projects and whatnot, so it wasn't unexpected, but normally you would get a project and you would just get your project done. That's kind of how I envisioned it, but there were so many people that have to work together in that project. So when you do these group projects, that's really how things will work in real life. In a lot of careers, maybe not every career, but in a lot of careers, you're going to have to work with other people. You're going to have to get minds together, solve problems, and implement solutions. And so I think to answer your question, I probably didn't consider it as much to the level that it was. Because again, there's quality engineers, there's sales, there's program management, there's your regular colleagues in your mechanical engineering group, right? Then you have to deal with management and all the management decisions, right? And you have your operations teams and the supervisors for operations. And then you have the operators that are actually going to run the equipment, right? You have a vast number of people that you have to interact with and learn from, because in a lot of cases, like the operators that are running the machines, we have to learn from them. We might have bought the machine, we might know how it works, but they're the ones that are running the machine on a day in and day out basis, so they're going to get to know the ins and outs of the machine better than we did, even if we bought the machine. They can tell us, hey, this piece right here, this doesn't work quite right? Every time I do this, this bad thing happens. And so then they can explain to us what's going on because they're there 8 hours a day, 10 hours a day running the machine. We bring it in, we go back and work on our next project. So we don't get to see that in and out as much as they do, right? And a lot of times you'll get more than one project. I mentioned that I had bought several machines at one time. 4 of those machines I was responsible for at the same time. So we were working on all of them together. It wasn't just I had one project, one machine. I had several projects that I had to manage and work on. Right now I have about 12 projects that I'm working on in my current position. So it's very common that you're going to get different things. But what I love about that is that every day it's not the same thing. It's something new every single day. If I was an operator on the line, there's nothing wrong with that. I would know what to expect just about every day. I'm going to put this, time to make the donuts. I'm going to take this widget and I'm going to stick it in this piece of machinery right here, and then I'm going to hit a button, and I'm going to unload this widget and put it in the bin. I'm going to take the widget, I'm going to put it in the machine, I'm going to unload the widget, I'm going to put it in the bin. It's going to be the same thing day in and day out, but with engineering, that's not the case. Every day is different. Every day, the project moves along, and it's different, and each project is different. And so that's one of the things that I really appreciated about engineering. So I know, again, that you guys might be interested in this. So we have some details on starting wages. How much do you think a starting wage would be for an engineer fresh out of school these days? Yes. 40,000 is a little bit on the low end now, but yes. What I didn't mention, and I can go into that in a little bit more detail, is that it could be 80, it could be 40. It depends upon what type of engineering that you're going into, right? There are a plethora of different engineering fields that you can go into, and that's part of what that is. And again, we'll hand that out at the end. But there's biomedical engineering. That would be one that would be a higher end. Chemical engineering, civil engineering, computer engineering, software engineering, construction management engineering. That's the thing. There's construction, they have engineers that work to build construction. Electrical engineering, environmental engineering, mechanical, survey and engineering, quality engineering, industrial engineering, geological engineering, materials engineers. There's even a thing called Imagineering. Do you know what an Imagineer does? They design roller coasters for Disney. How cool will that be? Well, that's why you have to engineer it such that that doesn't happen. Yeah, or Cedar Point where a chunk flies flying. But there's a huge range of salaries. So the survey and engineering, for example, that's the lowest one on this list. And I just Googled this, right? I don't have all this information just in my head. I just went to the internet and I Googled different types of jobs. But the lowest starting level engineering job was the survey and engineering at $32,000 mean. Do you guys know what mean means? Average, yeah. So the average job for a survey and engineer starting out of college is about $32,000. So then it looks like the highest one of just the ones I picked was 75,000. Can you guys guess what that one was? Close. Computer science. So computer engineering, right? Computers are very growing business, even though it's part of our life today, right? But because of that, it's a very high demand field, and so the price for engineers goes up and up. Biomedical was 62,000, so it could be in that range for sure. So there's, again, a huge range from 30,000 up to 70, almost $80,000 for a starting out of college, depending upon what your career is and what type of engineering you want to go into. So now we have the mean annual salary. What do you think a mean annual salary is for engineering? Just the average person, not after they've been in the job for a while, huh? Just in general, yeah, I guess. $80,000 is definitely possible, but that's on the low end of what the mean average salary is based on this Google research. Nice. Yeah, mechatronics. Well, the nice thing about Kettering is that normally the company that you're working with while you're in school is the one that hires you. So that does a couple things for you. I know they had a deal with GM that while you were in school and working, you would gain seniority at the same time. So the time that you're in college, you would work 3 months, go to school 3 months, work 3 months, go to school 3 months. All those times that you are working goes towards your seniority. So when you retire at the end of the year, or at the end of your career, all of your schooling counted. So your actual work time it can be shortened. So that's a benefit, but yes, a higher wage, because now they know what your work ethic is. They know all about you. You've been working for them for 2 or 3 years, right? So you're not coming in as an entry-level person anymore. You already have experience, and not just experience in engineering, but experience in their company. So you could go to school and you can learn all this stuff about engineering and math and science and whatever, but when you go to start your new job, you still have to learn your job. Right? You have to know the company's procedures. You have to know the company's documentation. You have to know who to talk to. There's all kinds of things that you still have to understand about the job. So in that example, you're graduating from school and you already know everybody to talk to. You know the team, you know the process, you know the procedures. They don't need to invest in you to train you because they've already done that. So you're automatically coming in not as an entry-level position. So yes, that's a great example of what opportunities are available. So again, we'll look at the survey one because that was the lowest one before. So the survey and engineer mean annual salary is $70,000. So that's, again, average salary. So then computer science, if we want to look at that, just so again we can get in the ballpark, that is $126,000. So again, that's about $56,000 range between what was on the low end to what was on the higher end, okay? And again, that's the mean. So what does the mean mean? Average, so that means there's higher and there's lower. So don't necessarily think that this is what you're gonna do in 10 years, that you'll be right at that rate. You might actually be higher than that rate, or maybe you're still working up to that rate. Again, that's the average of all engineers in that range. So it gives you a great picture of what's available. And then it's interesting here, the top 10% of computer engineering is 192,000. So that's like in the top 10%. So you could do pretty good, right? You might even be able to buy a snowboard. A gallon of gas. Yes, be interesting for sure. So if you want to, you can start handing those out now. So what I have here in this little handout is, so there's an entry-level mechanical engineer. Most people, when they think of an engineer, they think of a mechanical engineer. That's probably the most common. And this is the average entry-level salary in Michigan. And again, where you live matters, right? You're going to make more money in California because the cost of living is higher. So, but in Michigan, it's about $50,000 is the average starting salary. So about $23 an hour now. And then the quality engineer is a little bit less, 44,000, about 20 bucks an hour. So in that range, we talked earlier, what would you expect to get? $40,000 to $50,000 is not unheard of to start off for most engineering positions. So what is median? We talked about mean. What is median? The exact middle. Yeah, so you take all these numbers and you look at the median, the middle wage for an engineer is about $90,000. 91, it says. You'll see that on the chart there. I think it's the second chart over here, right here. Yeah, I squeezed them all into one so I didn't have to print like a whole bunch of different pages. So hopefully you guys can read that. If you have any questions, just raise your hand and I can explain it. But what else, what other questions do you have about engineering or engineering fields do you have? Yes. That's a great question. So the question, if you didn't hear it, was how easy is it for you to leave the office and leave your work at the office and come home and actually be home and not be thinking about work all the time? I think it depends on the person. I've worked with different people that were just built to be workaholics, if you will. When you were in the office, and again, the interesting thing, the reason why I chose the job I have now is because I don't have to be in the office. My job now is a remote position. They actually shipped my computer, my monitors, keyboard, everything to my house. So I set up a home office, and I never have to go into the office to go to work. So that works great for me. It gives me flexibility to do things like this. But it does potentially give you an opportunity to have a harder time cutting the switch off, right, when it's time for work to be done. Our life is such that we're busy enough that there's almost always something to do in the evening, so I have to be done. I'm leaving work because we're going somewhere else, or there's a different activity. But there's a lot of people that can't shut that off. They just continue to work all the time. And even if they were in the office, they would go home and continue to work. That's not to say that I can't check an email here or there, or because it's at home, it's in the computer. Even when I was at work, I would go into the office, I would still check emails periodically, because to me it made my job easier when I could prepare myself for what was going to happen the next day. If I left at 4 or 5 o'clock and an email came out at 5:30 that was going to affect my day tomorrow, I would rather find out about it the night before than find out about it when I show up at 8 o'clock in the morning, right? So sometimes you can check an email, you could do a few things, but it doesn't necessarily have to consume you. And that's where I think the question you're getting to. Can you have a family life? And I would say absolutely. It depends upon how your brain can function. Some people need to be in the office, so that commute home is how they're turning their brain off from work. That time in the car where they're driving, listening to music, they're kind of checking out of work, if you will, and that they can shut their brain off and then start thinking about their evening. Some people have to process that way. For me, I don't personally have that issue. I walk out of my office, then I can work on my day, whatever's going on with the family. I don't have an issue with that, or at least a serious issue. Sometimes there's the middle of a major project, and I'm thinking about, I need to get back there to go work on something, but that's Very rare, and it just depends upon what's going on. Sometimes there's a deadline, right? And so this comes in seasons, right? With a project, there's a deadline. We have to put in a little extra work to meet that deadline. But once the deadline's met, now things can go back to normal, right? And that's kind of like with your school projects. Maybe you have a report that you have to do. You're not writing a report every day, but sometimes, okay, this report's due on Friday. I need to ramp up and get that work done, so I'm not waiting until Thursday at midnight to continue working on my report, so I can get it done early. So some of that's just planning ahead, right? The thing about engineering, and just like group projects, sometimes you have to wait on other people. You could get your part done, but you can't get all the information from everybody else because they're not getting their part done. But that happens, I think, with any career, just about any career. You're always going to be relying on other people to give you information, right? So I think, again, to make a long story short, it depends on the person. It's definitely possible if your brain allows you to do that. Good question, though. Any other questions? I probably didn't. So right now I'm an advanced quality engineer. So right now I work in quality. Again, my responsibility is to help make sure that current projects that are getting ready to launch, getting ready to start production, have a good quality system, documentation in place, trained operators, work instructions, all of the pieces to make sure there's a good quality system. And I chose this job, again, because I could do it remotely. So right now for my company, we have manufacturing in Mexico, in Ohio, and in China. And so I can remote meetings to all those places and talk about documentation, right? I don't have to be on the shop floor to talk about documentation. That's why she was making a joke about me being in meetings. What do you do besides sit in meetings all day? Because that's basically pretty close to what I do. But some of those meetings, I'm leading the meeting because I'm driving the documentation updates or changes. Some of the meetings I'm listening because I'm getting updates from other people on where the project timing is. And I'm listening for risks, right? Risks to the project that's going to affect our customer, or issues that are currently happening that will affect our customer, right? So those are the things that I'm looking for now. Could I have had an engineering job? Yes, I could have had an engineering job, but then I would be in the plant every day, most likely, or in the tech center, or traveling a lot of times, right? It depends upon what kind of job you have. And so I didn't want a job where I had to travel a lot. I didn't want a job where I had to, it would have been okay if I had to go to the office every day, but when you have the choice of not having to go to the office every day, for me, that was a better choice. And so I actually chose this position and took a pay cut so that I could have this opportunity to stay home. Because to me, that was more important, to be with the family and to have that opportunity. Most definitely, I would say computer engineers are in high demand. And again, those salaries are what helps drive that. But even mechanical engineers, there's always going to be a need for mechanical engineers. Electrical engineers, I would say probably for demand, maybe even more so electrical engineers, because that kind of bridges almost to computers, right? Everything needs to be wired. It all drives off electricity, in the programming and that kind of thing. So that would even be a higher demand, I would say, than just a regular mechanical engineer. But that's why they started blending the mechatronics. That I think was Jaffer up there? Yeah. That's what Jaffer was talking about, mechatronics, right? Because now you have mechanical and electrical, and then you have the robotics all built in together, right? So they've recently, within the last, decade or so, kind of created that new blended engineering for mechatronics. Because again, in manufacturing, now you can have one guy. You don't need to have a mechanical guy who doesn't know much about electrical, or an electrical guy who doesn't know much about mechanical. You can kind of put them together and have a blended degree. And so for companies, that's worth a lot more to them, right? Absolutely. It is fairly new because they didn't offer that when I was in school. It wasn't an option. So I don't have an electrical engineering background, for example. So I don't have that skill set. So when I worked in the plant, even when I was the engineering manager, I had a team of people. I had about 20, 21, 22 people who worked for me. And I had an engineering group that had some electrical engineers and some mechanical engineers because we didn't have mechatronics engineers. So that, we had to hire two people when we could have hired one. Or maybe we needed 3 or 4 people when we could have got away with 2. Or you kind of understand the leverage that gives you when you have somebody who has a skill set in multiple areas. And the others, it's for the machining, is CNC programming. So, you need machinists that can operate the lathes, right, and the CNCs, but you also need people who can program the CNCs. And that was also in demand, and that was what our electrical engineers did. And so that piece of that programming that they'll get from that degree puts them at a higher demand, right? Yeah, program it, operate it, and troubleshoot it. So there's a lot to it. All right, a couple more questions? These are good questions. Who was considered, besides Jaffer, who was considered engineering before? Has that ever been something that's crossed your mind? So what field of engineering do you think you would be interested in? Mm-hmm. Yeah, absolutely. What about you? Computers also, or? Yeah, yeah, and that's great. That's awesome. But a lot of times the engineers, just to help put some thought behind that, sometimes they're constrained by other things. So in project right now, I have a project that they put the design together and it failed validation. So some of the validation requirements are more than just what a regular vehicle would go through on a day-to-day basis. They have to live like 10 life cycles. So the engineering design has to be way bigger, way more efficient and durable than what most cars would have to endure. That puts restrictions on what the engineer can do, and they have to do it within budget. So sometimes now you failed validation, you've already spent the money to get this design and it doesn't work. So now you have less money available to you to change the design and get a new part, redesign the widget or whatever is failing, and then revalidate it. And so sometimes things happen because something didn't work right initially, and then they had less time, because again, we have a deadline that we have to make this ready for vehicles. Specifically, cars are a big deal. People ask questions all the time, why do they do it that way? And it could be because they had to get it into a package to fit. Maybe they had a constraint that it has to work in this vehicle and those 3 vehicles over there also. And so what doesn't make sense for this vehicle maybe makes perfect sense in a sister vehicle over here, but they wanted one part number. And so you have to design it such that you can make it work with one part number, even though it would have been better for this vehicle to have it a little different. But yeah. Mhm. In some cases. In some cases, I mean, that's not across the board, but sometimes they want to commonize, right? Because every individual part number costs more money, because now you need to manage that part number, inventory for that part number, floor space to hold all the extra parts for that part number. If they can commonize things and make things common, then the cost comes down, the overall overhead cost for the plant comes down, but maybe you sacrifice a little bit of efficiency in certain areas to save that overall cost. Does that make sense? So there's trade-offs, right? Again, that I mentioned before about everybody else has different goals, right? Management, and I didn't mention them, but they have their own set of goals as well, right? And so when you have a project, there's things we call flawless launch. And for flawless launch, you have to make sure that you're delivering it on time. Your FTQ, your first time quality, is a certain level, which is agreed to in the project. Obviously, you have to come in under budget to be a flawless launch. You have to consider how many people does it take to make this widget? How many operators do I need to have? So your head count needs to match, and your cycle time. So maybe you did all those things and you're making good quality parts, but it's taking you 2 seconds longer to make each part than what you're supposed to. You'll still fail the flawless launch because you're not making them fast enough. So now it might mean you have to run overtime to make the customer's demand. And so that's why they're looking at all these metrics across the board, because again, the plant, the management wants good quality, they want all that, but they also want it at a good price because there's a margin, right? We quoted the business at this many dollars a piece, and so if we're running overtime, our labor cost is higher than what we budgeted, so we're making less money. Does that make sense? So you want to make sure that all of those metrics are met so that you have the ability to make whatever margin was intended to make for that part. They have what they call overhead, and overhead would be the structural costs to run the plant. So your heating, your lighting, those types of things, but then you have labor costs, and so again, how many operators? And you have direct labor and indirect labor. Direct labor is actually working on that part, on those machines. Indirect would be your electrical engineer, or not the engineer, your technician, electrical technician. Engineers would be a part of the overhead, but your technician that's actually supporting it, when something breaks, they can come in and fix it. Or maybe they calibrate the machine just on a frequency to make sure it continues to run well. So you've got these people that are indirect. You have a material. Most plants nowadays have what they call tugger drivers. And the tugger drivers would drive around to each of the machines and deliver parts, components that they can then assemble into whatever they're making. And so that material delivery person is an indirect operator, and you have to account for that because that's money. You're paying them wages, you're paying them salary. So for each project, that is amortized over each piece that you make into a piece price. So then you have to put the profit margin. Can you hold the button down? It should be on. You have to light on. There was also a mute thing. Yeah, that. There you go. All right, sorry. Yeah, that was getting cut off. So anyway, when you sell a part to a customer, you have all these different pieces: the overhead, the factory margin, the profit. Those are different things that you build into a piece price that helps you know what you want to sell your part for. And so most people want an operating income on their part, 10 to 15% is what most people want to make a profit on their part. Sometimes you'll sacrifice that, you'll make a little bit less because you're just now starting to do business with this customer. And so you have to get your foot in the door, right? So you may take a little bit lower profit, but then you want to try to ramp your profit back up. And again, that's just in general. There are pieces of technology that are so unique and you have a patent on them, you might have 30% operating income. You might have a huge margin because you're the only one that can produce it. Nobody else can make it because you have a patent and your customers want it, right? A lot of the technologies, if you think about the safety features on cars now, or even the electrification of vehicles that allows them to get closer and closer to self-driving cars, those things are in high demand, right? Because people are looking to have cars like the Jetsons. You guys know what the Jetsons are? Where everything's automatic, right? You can just hit a button, and you see cars, they're advertised now. You can hit a button, and you see how they pull their hands away? The commercials always crack me up because they pull their hands away very slowly. Why? Because it kind of freaks you out. If you're, do you trust the car that's going to do what it's supposed to do? There are so many things that have to work just right for that car to continue to follow the road, for it to, stop by itself and all those things, right? You have to have a lot of faith in the engineers that designed the car, in the operators who built the pieces, right? And in the equipment that made it, to know that all of it was assembled correctly, the components were designed correctly, the sensors work, they didn't fail, right? It takes a lot of trust and a lot of faith in that. So the commercials are always like, they'll have the steering wheel and they'll slowly pull their hands away. Kind of cracks me up. Yeah, and I don't know if, I don't know that I would ever be able to just fall asleep and just trust that the car would get me there. But I don't work in that piece of the industry directly, but I would imagine that there's definitely some level of cybersecurity, but I don't know to what depth that they go. I'm sure there's encryption and things of that, but yeah, we've seen the movies where they turn cars on and make them drive off and crash into people, but they're also movies, so. Could be. Yeah, let's hope that doesn't happen. All right, any other questions? I don't know how much time we have. Okay. All right, well, thank you.